like to know,
Yep, please ask
uh,
me.
no, I was going to ask you about the recording only. And do we get the recording as well? Uh,
Yeah, I have a YouTube channel, so we'll put this recording on that channel as well.
okay, great. ठीक है. Thank you.
So
Just
yeah,
wanted to ask that only. Yeah.
yeah. So we'll okay. Let me tell you how to do the all the notation, the set notation first of all. Okay, are you able to see the screen there? My screen.
Yes, yes. I'm able to see your screen.
Okay, so there's a first method we called as the roster notation. Roster notation. So actually roster notation is what? Roster is what? It's just a list of element of all the element of the set in a set. Okay, and it's just separated by commas, right? And then they are surrounded there. We have the curly brackets there. Like if I say 1, 3, 5, 9, 10, 15. So this is a roster notation of a set. Okay. Understood, guys? Is there a doubt? Okay, cool. And then there is a second method as well to write down the notation that we call the set builder notation. And for that, you need to remember three things. The method to we call that set builder notation. So for that, we should remember the three things. Like how do we notate the like real number, or you can say denote. So real number we denote by R. Z is integer number, and N R natural number. Okay. Suppose if I give a set and the set is like this, X belongs to Z and X is greater than equal to 2 and less than equal to 6. So what does that mean? So that mean is actually all X that are elements of set of integers, right? So actually X belongs to what? Integers. So all the X are integers. First of all, this is the condition. And the second condition is X is greater than equal to 2 and less than equal to 6. Correct, guys? So if I write down in just, roster notation, so what will be that? So that will be because X is what? All the integers, and it is greater than 2 or equal to 2 as well and less than 6. So it can be 2, 3, 4, 5, and 6. Understood this, guys?
Yes, sir.
2 and 6 inclusive. Right, guys? Any doubt till here?
No, sir.
Okay. I'm just giving you one more example of this, the set builder notation. The another is like X again belongs to what? Integer. Okay. X belongs to integer and X is greater than 0. Right? So what does that mean? So that means definitely it belongs to what? All integer, like 1, 2, 3, and what is X? X is greater than 0, so it can be infinite. Right, guys? Is there any doubt? We'll not consider 0 at this time because this X is just greater than 0, not equal to 0. Correct?
Okay, sir.
Okay. The next one is method 3. We have already done this in the last class, but I'm explaining one more time. So by interval notation. Right? So before that, let me tell you there are two brackets. The one is like this. The one bracket is like this. This means not included. Or we also call this open bracket or open side or open interval, right? The another one is like this. It's not that much like this. So this means included, or we also call this closed interval. Okay, are you getting till here, guys?
Yes, sir.
Is there any doubt till here?
Yes, sir.
Okay. Now let me write down how this works. What is the open interval? What is the closed interval? What is left open interval? What is right open interval? So it's like open interval. So open interval is like, suppose you are given A, B, suppose A and 5, 1 and 5. So X belongs to what? 1 and 5, belongs to what? Any of the integer or whatever. But X is what? Greater than 1 and less than 5. It means X is greater than 1 and less than 5. So we discussed on the number line as well in the last class. So it's something like 0, 1, 2, 3, 4, 5. So on a number line, it will be denoted like this: 1, 2, 5. But these two will be what? Hollow. It's not like a dark one, right? Because this is just greater than, not equal to. Understand?
Okay, sir.
Now another one is the closed interval. So closed interval something, suppose I give you like A, B, or we have 1 and 5, close both sides. So that means X is greater than equal to 1, less than equal to 5. So on a number line again, if I make it 0, 1, 2, 3, 4, 5, right? So it is between what? 1 to 5, but both sides we are including 1 and 5 as well. So it is dark on both sides. Right, guys? Is there any doubt?
No, sir.
Okay, cool. Then we have the left side, left open interval. So from the name only, you can say, because it's left open and the right is closed. So it's like A, B. So X is greater than A and less than equal to B. So again, you can say, suppose X is, greater than 1, less than equal to 5. So how do you denote that? 0, 1, 2, 3, 4, 5. So it's between 1 to 5. But at 1.
1 is hollow, 5 is rounded.
Yeah, darker. Okay. And then we have the right open interval. Then we have the right open interval. In the right open interval, we write down the right hand side open. So it's like A and B. Right hand side is open. So this is something x is greater than equal to 1 and less than 5. So on a number line, we write it down like 0, 1, 2, 3, 4, and 5. Okay. So we'll 0, I mean 1 to 5. So at 1, it will be dark and this will be the whole area. Understood this, guys?
Yes, sir.
Any doubt till here?
No, sir.
Okay. We had done a little bit of the operation of the set. Should I explain it one more time? Like the intersection, union, and we had done the complement last time. Okay, let me tell you all three quickly. So these are the operations of the set. There are three operations of a set. They can be more than that. They can be, but these three are important, right? So one is intersection of the set. Second is union of the set. The third one is complement of sets. Right, guys? So first one, you know what is the intersection, right? Okay, so what is the intersection? Suppose, okay, if I take the two
The unique one.
yeah, two set, or if I'm making using the Venn diagram only. So this is like A and B. So you have the A
element which is common in both the systems.
intersection means those are in both, right? So this part that we can write down A intersection B. Okay. Also we make this, so we write it down as union. Union means every element will be there, right? And then oh sorry, U is universal, not union. So now 2 is what? Union of the set. So if I take the union of the set, so like there are two Venn diagram again. Okay. So it's like if I'm taking this, so like every single, the element of the both set will be the union, right? So like
Yes,
A,
sir.
B. So A union B, we denote the intersection as A intersection B. Okay. Now, the most important is out of these three is the complement of the set. So what is a complement of a set? So when you have the universal set, okay, and suppose, okay, you have given the universal set U as 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, and 11, and 12. You have given this universal set, right? You have given the set A as well. Set A is 3, 4, 5, 7, 9, 10, 12. Correct? Now you need to find the A complement. So you can write down the A complement like this: A, C here, or A bar, or A like this. So all three are the notation of the A complement, right? So A complement means all the elements from the universal set, universal set those are not in set A. Okay, so what will be A complement there? So can you tell me those number of those elements, those are not in
1, 2, 4, 6, 8,
4,
yeah, so
11.
yeah, okay, so you check the universal first of all and you write down the elements, those are not in A. Okay, so 1 is not in A, 2 is not in A, 3 is in A, 4 is in A, 5 is in A, 6 is not in A, 7 is in A, 8 is not is in A, 9 is in A, 10 is in A, 11 not is in. So A complement is 1, 2, 6, 8 and 11. Understood this, guys?
yes, sir.
Any doubt till here?
No, sir.
Anyone? Please ask me if you have doubt. No doubt? Okay, let's move to the next example of this. Suppose you have the set E 2, 3, 5, 7, 11, and 13. Set F 2, 5, 7. You need to determine the complement of set F within set E. So what you need to find? You need to find the complement of F, right, within set E, right? That means you need to find the element of E, those are not in F. What you need to find exactly? Element
3, 11, 13.
of set E, those are not in set F. Yeah, so what are those elements? 2, yes, 2 is there, 3 is not there,
3, 11, and 13.
5, 7, 11, and 13. Yes. So complement of E, or you can write down EC, that will be equal to 3, 11, and 13. Is there any doubt, guys?
No, sir.
Understood?
Yes, sir.
So complement of set F, है ना?
Yes, it is. Okay. Let me give you one more example. Given the set of numbers on a standard 6-sided die, which of the following represents the complement of the set comprised of all the multiple of, sorry, 3, not my bad. Okay, I'm just putting some example there. I mean the answer choices. 1, 2, 3, 2, 4, 6. 1, 2, 3, 4, 5. 1, 2, 4, 5. Okay.
Sir,
So-
option D.
Sir, the last one.
Yeah, this is MCQ question. First of all, okay, let me tell you how to solve this. Okay. Now, what you need to take there, first of all, what is given to us? Given the set, we are given a set of the numbers on a standard six-sided dice. So what are the number on a six-sided dice? 1,
1,
2,
2, 3, 4, 5, 6.
4, 5, 6, right? That is the dice of a Ludo, right? So we have the 1, 2, 3,
Yes,
4,
sir.
5, 6, correct? And then we need to find the complement of the set of multiple of 7. So what are the multiple of, sorry, 3? Again, I'm telling. Okay, what is the multiple of 3 there? 3 and 6.
3 and 6.
Right? You know the multiple is like multiple of 3 is 3 times 1 is like
3
table.
into 1, 3 into 2.
Yeah, 3,
Yes, sir.
2 is multiple is 6, 3 times 3 multiple is
Yes, sir. Yes.
9, right? So these are the multiple. Now you need to tell, okay, so what are the number? Those are in set, the main set, but not in the, this set, the multiple of 3. So what are those number? 1, 2, 4, and 5. Understood this, guys?
Yes, sir.
Any doubt?
No, sir.
Understood this, guys? Is there any doubt?
No, sir.
Okay. Okay, I'm just putting a table there.
No problem.
No, I'm putting the table on the this screen. Can you try? Everybody try. I mean, quickly solving this. Okay, first of all, let me tell you the first one. So first one is what? House, and this horse, HOUSE and HORSE. So what we need to tell? Union. Union is what? You add all the elements of the both set, right? So what will be that? H, O, then what we have? S is also common.
U.
First, you can write down the common. Those are common. E is also common. And then U, and then
Say
R.
U.
So, and the intersection is what? We just need to write down. Those are the common. So what are those common? In both set?
HOSE.
Yeah, HOSE. Okay. Can you do quickly the other one? I'm just giving you
Yes, sir.
all of you 2-3 minute time.
One, 2, 3, 4, 5, 6, 7, and 9.
And the other is 1, 3, and 5.
1, 2, 3, 4, 5, 6, 7, and 9. 1, 3, 5. I think 1, 3, 5 only. Yeah.
Yes, sir. 1, 3, and 5. And other answer is even and odd both at first, and then odd only. Even and odd both.
Right.
And other one is
Second
odd
one
only.
is only odd.
Odd. Mm, And another
Odd
answer is
comma.
Next
table
one
and
is PABLE sync, and another
Yes, I
is
only
one
both.
not phi.
Yeah. So what is a union of table and sync? So table T
Yes.
is there, A is there, B is there. I think every element is different in this case, now, right?
Yes, sir.
Yes.
It's table sync.
And what
Yes.
is the intersection?
And
Because there is no common
Phi.
element there, so that will be phi, or you can say
Null.
null.
3.
Okay. What about this? Actually, if you see this now, so the next one, right? So these are the multiple of 3 and these are the multiple of 4,
Yes,
right?
sir.
So what is common there? I think first of all the 12 should be common, right?
So 12 and 24.
And 16 is not there, 24 only, right?
24.
So 12 and 24. Oh, sorry, this intersection is
So
there.
common.
Yeah, intersection is 12 and 24. And what is there in everything? Union, so you can take it like 3, 4, and then 6, and then 8, and then 9. You can write it down like this. Okay.
It goes very long, sir.
Yeah. Okay, next one is important. What is this saying? This is saying x is such that x is greater than 1. So you can write it down in the this form as well. 1 greater than 1. So it can be like 2, 3, 4, 5. But it doesn't say like x is integer or what. Real number, or I mean the whole number, right? Or natural number. But in the second case, what is it saying? X is what? Greater than equal to, less than equal to 1. Okay, so it can be like it from infinity to negative, suppose 4, -3, -2, -1, 0, and 1 as well, right? So if we take the intersection there, I mean, yeah, if we take the
Only
intersection there, so intersection is what? Yeah, nothing is
Infinity.
common there. Nothing is common, right? Because that is greater than 1 and that is
Oh, yes, sir.
less than equal to 1. Correct? So nothing is common, right? So
Fine.
intersection will be what? 5. If we take the union, union is everything there, like x is,
Minus infinity to plus infinity.
yeah, minus infinity to positive infinity. Okay, next one.
Interaction is 10 and 15. They are the unique ones. Yeah. So only the 10 and 15 are common there.
10 and
15.
15. Okay, and union, so it will be, yes, 1, 3,
Yes, or
6, 10, 11, 12, 13, and then 14, 15, 21, 28. Yeah, and the intersections are 10, I think,
10 and 15 only.
15 only.
15.
Okay, understood this, guys? Any doubt? Anyone have?
No, sir.
No doubt? Should we move further?
Sir.
Okay. Okay, this is important question. If the universal set is U equal to like A square, also 1 square, 2 square, 3 square, 4 square, 5 square, 6 square. What is the complement of the intersection of set A, that is 2 square, 4 square, 6 square, and set B, that is 2 square, 3 square, 4 square. Okay, let me put the answer. This is MCQ question. So the answer is 2 square, 4 square, 1 square, 5 square. C is 1 square, 5 square, 6 square. And D is 1 square, 3 square, 5 square, and 6 square.
Sir, option D.
Option D.
Okay,
Mm.
let us do. And you take the guys 2 minutes quickly and read this, understand this, try to solve this, then I'll let you know. Okay. Let me tell you guys quickly. So first of all, what we need to focus on, we need to focus on, so what is the intersection of set A and set B? Okay, so A intersection B, what will be that?
2
So
square and
2
4
square
square.
and 4 square. Okay,
4
and
square.
yeah, and then what do you need to find? The complement
Complement.
of A intersection B, right? So that means those elements, those are in the universal set, but not in the intersection of A and B, correct? So those are the 1 square, 3 square, 5 square, and 6 square, correct? So if you
Yes.
see this, yeah, in the answer choices, so what do you get? So you get as D, correct answer. Is there any doubt? Right?
No, sir.
No doubt. Okay, I'm just ending this class. You can just rejoin using that link.